Hello and welcome to Lesson 5J. I can classify and prove polygons using coordinate geometry. Today we're going to learn about coordinate proof, and coordinate proof really is a way for us to take a set of four coordinates and then to prove mathematically what shape those four coordinates form. And we have three major tools that we use to prove different types of quadrilaterals. The first tool is slope formula. And slope formula we've been using since, of course, Algebra 1. It's y2 minus y1 over x2 minus x1. And slope formula can show if our sides are parallel or perpendicular, and it can also show if our diagonals are perpendicular. So we will use slope formula a lot. Our second major tool is the distance formula. D equals the difference of the x values squared plus the difference of the y values. Oh, I missed a parenthesis. Difference of the y values squared and take the square root. The distance formula finds the length of segments, and it can show us if we have congruent sides or congruent diagonals. And finally, we've got the midpoint formula. And my midpoint formula is xm comma ym equals the average of the x's comma the average of the y's. And the midpoint formula will show if diagonals bisect each other. We're not going to use him very often, but he is a tool that you could use if you wanted to. Generally speaking, when we're doing these problems, we're going to follow three basic steps. Our first step is to graph the points. We're going to graph all of our points in a coordinate plane. And then our second step is to find the slope of each side, because the number of pairs of parallel sides give us our three major categories. Is it a parallelogram, is it a trapezoid, or is it a trapezium? And then once we do that, depending on the results from step 2, we'll then find the lengths of needed sides as we need to then further classify our shape. So if it's a parallelogram, and in this step I also determine if it's a rectangle. If it turns out it's a rectangle, I'm going to test to see if it's a square by finding the length of consecutive sides. If it's, on the other hand, not a rectangle, I'm going to test to see if it's a rhombus by also finding the length of consecutive sides. Whereas if I get that it's a trapezoid, I have to test for an isosceles trapezoid by finding the length of non-parallel sides. So that would be finding the length of these guys, right? If those are congruent, then we know it's an isosceles trapezoid. Trapeziums are the most finicky. We get that there are no parallel sides, and when that happens, I need to test to see if it's a kite by finding the length of all four sides to see if you've got two pairs of consecutive congruent sides. So these are our basic steps. Let's do a problem to show. So now I want to classify the quadrilateral with vertices E at -6, -1, F at -9, -3, G at -8, -7, and H at -5, -5. So let's graph those points. So we've graphed the points. I've also labeled my vertices as I'm doing this because it will help me out. Just looking at this, my knee-jerk reaction says that looks a little bit like a rhombus. But I don't know for sure that that's a rhombus. What I need to do is actually do the math to prove that it's a rhombus. The point of a coordinate proof is not to get the final answer. It's to prove definitively with math that the shape you see is the shape you think it is. So what I'm going to do first, I've done my first step is graphing. My second step is to find the slope, okay? So I want the slope of EF, which would be -3 minus -1 over -9 minus -6, and I end up with -2 over 3, -2 over -3, or 2/3. I'm going to do that for each side now. I'm going to do the slope of all four sides. The slope of FG. I work it out and get -4. Now I want you now to go and do the next two slopes on your own. So I got that the slope of GH was 2/3 and the slope of EH was -4. Now I look and I see how many pairs of parallel sides do I have. I've got one pair that's -4, another pair that's 2/3. We then would write that EF is parallel to GH and that FG is parallel to EH, which means with two pairs of parallel sides, I know it's a parallelogram because I have two pair of parallel sides. Now, I've discovered it's a parallelogram. I can also look and see here that it's not a rectangle because these guys are not perpendicular. Not perpendicular, so it's not a rectangle. So part of your proof is proving what it's not, right? So what I want to determine now, it's a parallelogram. Looking back at my flow chart here, from the parallelogram, I've gone to this box now. I know it's not a rectangle, not parallel. So I want to find test for rhombus. Is it a rhombus? So I'm coming back over here to see is it a rhombus? All right, so let's take a look. I want to find the distance of two consecutive sides. So I'm going to do side EF. EF equals the square root of the difference of the x values, -6 minus -9 squared, plus the difference of the y values, -1 minus -3 squared, which gets me the square root of -6 minus -9 is 3 squared plus 2 squared, which ends up being 9 plus 4, or square root of 13. That's EF. Now let's look at FG. FG equals, I do the square root of, FG is -9 minus -8 squared plus -3 minus -7 squared, which gets me the square root of -9 minus -8 is -1 squared plus 4 squared, or square root of 1 plus 16, or root 17. So here's the thing. EF does not equal FG. Therefore, it's not a rhombus because my sides are not congruent. Because sides not congruent. So my final answer is parallelogram. This thing is a parallelogram. And guys, the whole point of this is to communicate really clearly what it is and what it isn't. It is a parallelogram. It is not a rectangle. It is not a rhombus. Tell me what it is and what it isn't, and use the math to support that. So let's do this next one together. I want you guys to go ahead and graph all 4 of those points. All right, we have graphed all 4 points. Now, I'm going to find the slope of each side. And this time, guys, I'm going to do it just by counting rise and run. So my slope of AB is, if you look, there is no rise. It's a rise of 0 over a run of 1, 2, 3, 4, 5, 6 over 6. 0 over 6 is 0. My slope of BC is, there's a rise of 1, 2, 3, 4, 5, -5 over a run of 0. Can't divide by 0. That's undefined. And then my slope of CD, there's a rise of 0, a run of 2, so it's 0. And then my slope of AD, well, when I go down 1, 2, 3, 4, 5, and then I go over 1, 2, 3, 4, I get 5/4. Now, looking at this, right here, I have one pair parallel sides, which means I know that this is a trapezoid because AB is parallel to CD, right? These guys here are parallel. Now, looking at this, I have a perpendicular side right here. We've got perpendicular going on here and here, but that doesn't really help me with the trapezoid. That only really helps me with the parallelogram. I now need to see, is it an isosceles trapezoid? Okay, so I'm going to do that by finding the non-parallel sides. BC is non-parallel and AD is non-parallel. So I'm going to find the length of both those sides. Guys, take a minute and do that now on your paper. So I end up with BC equal to 5 and AD equal to root 41. I therefore know that BC does not equal AD. Therefore, this is not an isosceles trapezoid. So what I can conclude that this is a regular trapezoid. That's my answer. All right, let's take a look at the next one. I want you guys now to go through and graph those 4 points for me right now. All right, so your shape should look something like this. Now take a minute and find the slope of all 4 sides. All right, I did all of my slopes by rise and run. You could also use the slope formula, but what's important here is that we have no sides parallel. So what can you conclude at this point? So at this point, I know it's a trapezium, and my next question is it a kite? And if it's a kite, I'm looking for 2 pairs of consecutive congruent sides. And so I'm now going to need to do the distance formula 4 times in order to know if this thing is really a kite. So take a minute now, guys, and do the distance formula 4 times to figure out if this thing is a kite. And so doing this, I get that both JM and JK are 5√5, which means that JM is congruent to JK, and they are consecutive sides. And then I get that ML and LK are both 5√2, therefore ML is congruent to LK. This means I have 2 pairs of consecutive congruent sides, therefore my answer is that this thing is a kite, because it's a trapezium with 2 pairs of consecutive congruent sides. And so would really like to write that as a sentence at the end of my proof. And there you go. Again, guys, the most important part of these is communicating what your answer is and why. It's not about the actual answer. It's about the work you do to prove that it is what it is. All right, I want you guys now to take a minute and look at number 4. I'm going to erase some of this. Go ahead on 4, plot the 4 points and find the slope of all 4 sides. So when I go through this, we plot all of our points and we get that QN and PO have the same slope of 2, but there are no other pairs, so we know it's a trapezoid because there's 1 pair of parallel sides. Now that I know it's a trapezoid, I need to test to see if it's an isosceles trapezoid. And to test for an isosceles trapezoid, I need to find the non-parallel sides. Well, these are my parallel sides. So my non-parallel sides would be the length of ON and the length of PQ. So now go and find the length of those 2 sides. So going through this math, we get that ON is 3, PQ is √17, and 3 does not equal √17, so it's not isosceles. So my final conclusion is that this is a trapezoid, because we have 1 pair of parallel sides. All right, guys, I now want you to go through and to try number 5 completely on your own. Be sure to show all of the work you need to show, and we'll go from there. Thank you. So at this point, we know that it's a parallelogram because I've got 2 pairs of parallel sides, because you've got a slope of -2/3 for 2 sides and 3/2 for the other 2 sides. Well, if you look at those are also opposite reciprocal slopes. And opposite reciprocal slopes show me that all of these segments are meeting at right angles in here. So we know also that this is at least a rectangle. So now I want you to take a minute to decide what you should do from here. What do you test for next? And what I want to ask myself, is it a square? And to test for a square, we're going to look to see if we have a pair of consecutive congruent sides. So go ahead now. I'm going to look at the length of XY and the length of WX, because those are consecutive sides. If they're congruent, it's a square. If they're not congruent, it's just a rectangle. Take a minute and do that. So when I find the length of segment XY, I get √13. And when I find the length of segment WX, I get 2 √13. XY does not equal WX. So this is not a square. Therefore, I fall back and realize that it's just a rectangle. And that's my conclusion for number 5. All right, guys, let's talk about these next 4. They're a little bit more abstract, and then we'll get you into the practice assignment. This is all about finding the coordinates of vertices given things that we know about them. So for example, a square with a side length of 8x is centered at the origin. So let's draw that. Here's my origin. Square centered at the origin is going to look something kind of like that. And now if I know that my side lengths are 8x, that means this whole thing is 8x. That means that to come out to over here, this over here has to be over 4x, and this has to be over -4x in order to get these actually as vertices. And same thing up here. So this point up here would be at the point 4x comma 4x. This one would be at the point 4x comma negative 4x because my y value's gone down. This guy over here would be at the point negative 4x 4x because my x value is going to the left. And this point over here is at negative 4x comma negative 4x because both of them are going to the left. Let's take a look at number 7. Given that AC, so from A to C, is 6q, which means if this whole thing is 6q, that means this has to divide up into 3q on both sides. And that BD is 10r, which means that this whole thing here has to be 10r, so both of these must be 5r long to split it in half. Find the vertices of the rhombus centered around the origin. So that means that the point C is at the point 3q comma 0. B is going to be at 0 comma 5r because it's 5r up. A is going to be at negative 3q comma 0 because it's 3q to the left. And D is going to be at 0 comma positive 5r. All right, let's take a look at this trapezoid. Given the isosceles trapezoid below, find the values of vertex E. So when I look at E, I know that it's going to have the same y value as this point right here. Well, this point right here's y value is 8b. And I also know that the value of E here is going to be, if I look at this, if this is an isosceles trapezoid, these lengths here must be the same. This length here is 8a. And so the length over here is 6c. So E ends up being the x value of 6c minus 8a to get that x value. And my y value is plain old 8b. And let's look at number 9. Number 9, I want to find the values of f and g. Well, f, if I look at this right here, the x value is definitely at a. And my y value is the same y value as this point over here, which must be 3c. So my vertices are at a comma 3c. Now point G here is a little bit trickier. If this point is all the way over at a plus 3b, if you look, 2 blocks are the equivalent of a, which means from here to here is the length of a. So this x value here, right here, must be a plus 3b minus a to get to G. My a's would cancel, meaning that G has an x value of 3b and a y value of 0 because it's sitting on the origin. All right, guys, take a look at the practice. We'll talk about these further in class. So thank you all very much.